Hi, I'm Chris from Flux Films, and I'm going to be talking to you today about the basics of electricity. Some important concepts to think about when learning about electricity are the concepts of current, voltage, and resistance, and how they relate together with a formula called Ohm's law. And basically, a good analogy for electricity is through water. So when comparing electricity to water, because it's a good analogy, you want to think about the way current works. So current is essentially, when it comes to electricity, the amount of electricity flowing through a wire in a certain amount of time. And it is similar to the amount of water flowing through a pipe in gallons per second, for example. But with electricity, the unit used to describe it is amperes. And it is also known with the variable name I when talking about mathematical equations. So yeah, current is just how much electricity flowing in a certain amount of time. Another important concept to understand is the concept of voltage, which is essentially the force or pressure behind the electricity. So it's also called electro-motive force, and it is measured in the unit of volt. So voltage is measured in volts, which sort of makes sense. And that's something you probably already heard of, like voltage of a battery or something like that. But essentially what that is, it is the force behind the electrons, pushing it through a wire or through a component or whatever. And it is analogous to pressure in a water system. And then the last important concept to understand is the concept of resistance. And that's essentially the resistance to the flow of electricity through a wire. So just like with a water pipe, if you close a valve halfway, you're going to get less pressure. The same thing is true of an electronic circuit. If you have a resistor, you're going to lose voltage across that resistor, just like you'd lose pressure with water. So resistors block the flow of current. And all of these sort of concepts relate to an important law known as Ohm's law, which states that voltage equals the resistance times the current of a certain component or system. So if you have a circuit that has a resistor in it, and you have, say, 1 amp of a current flowing through it, and it's a 5 ohm resistor, and ohms is the unit of resistance, you then would divide multiply the 1 amp times the 5 ohms, and you get that there's 5 volts across it. And this formula can also be rearranged in other ways to think of it as current equals voltage divided by resistance. So if you have, let's say, a 6 volt battery and a 2 ohm resistor, you'll get 3 amps of current. Some other important concepts to understand regarding electricity include the relationship between electricity and magnetism, and the concept of charge. Charge is simply an amount of electrons. So just like with water, a certain amount of water is considered a gallon, with electricity, a certain amount of electrons is considered 1 coulomb. And that relates to current. So I had talked about the current in amperes earlier. 1 amp of current is 1 coulomb per second flowing through a wire. And the other concept that I wanted to discuss is the concept of magnetism and how it relates to electricity. And there is a very important relationship. Essentially, whenever a current flows through a wire, it creates a magnetic field around the wire. And likewise, if a magnetic field is presented over a wire, it induces a current in the wire. And this is amplified if you have a coil of wire. So if you have a coil of wire and you run a large current through it, you get an electromagnet. So that's like what's used in motors to make them spin and that sort of thing. It's current going through a coil within the realm of magnets. And this is also what's used in generators to generate electricity. So when a magnet passes over a coil of wire, it induces a current in the wire. So that is the important relationship between magnetism and electricity. Another important concept in electronics is the concept of power. Power is essentially energy flowing over time. So the unit used for power is the watt, and 1 watt is 1 joule of energy per second. And essentially how this relates to electronics is you can multiply the voltage times the current, and that will give you the power. Another important concept in electronics is the concept of AC versus DC, or alternating current versus direct current. So you may have heard of alternating current or direct current before, but what they essentially are is that alternating current means that the voltage is constantly switching from positive to negative, referenced to a neutral point. So that's the kind of electricity that you'll find in household wiring, for example. So it's going positive, negative really fast. In the case of America, it's 60 times per second it switches. When you're talking about DC, it essentially means there's just a constant voltage and current will flow in a constant direction through the circuit. And that is what most of the basic electronics that we will be doing are dealing with, and that is when Ohm's law is most applicable. While Ohm's law is applicable in the case of AC, it sometimes with certain types of devices can behave differently than I have previously discussed, so it is important to consider other factors.